So I previously made a video on the square root of I, but that probably got some people thinking, what's I to the power I? What's I to the power I? Well, how can we rewrite this? This is going to take some intuition, but we know that the number e has a pretty significant correlation to I. So we can rewrite this as I to the power I is equal to e to the power x, and all this to the power I. So this just becomes e to the power x is equal to I. Now I'll give you a couple seconds to figure out what x is. If you watched my natural logarithms video, the first thing you might have come up with was ln I, natural log of I. Now mathematically, that is correct, but it doesn't really get us anywhere. Let's still try it out though. E to the power ln of I is equal to I. This becomes e to the power log base e of I is equal to I. Well, the log base e and the e just cancel out, so we just get I is equal to I. That didn't really get us anywhere. Okay, so this is not the first thing that comes to people's mind, but think of Euler's formula. E to the I pi is equal to -1. Say you have a unit circle on the complex plane, and you're on the x-axis, sitting on x is equal to 1. You know that you want to get to I, so you just have to move 90 degrees times I. Well, what's 90 degrees? 90 degrees is pi over 2 radians. So, we can just simplify all of this. This becomes pi over 2i. And this is what x is equal to. Now we can just plug all of this into x. E to the pi over 2i all to the power I is equal to I to the power I. If we simplify the left side, we get e to the pi over 2 I squared, which simplifies to e to the negative pi over 2. You can punch these numbers into a calculator and you get approximately 0.208. Now let's think about it. We started off with I to the power I, an imaginary number I to the power of another imaginary number I, and we ended up with a real solution, 0.208. That's pretty interesting.